Hello, everyone. OK, so I guess this is my cue to go. So I'm Maria, and this is LifeBit. Now, how did LifeBit started? Well, during our PhDs, my co-founder and I did a lot of work that led to the programming framework now used by half of the world's organizations doing DNA data analysis, and 4 of the top 10 pharma companies, right? So that was just the beginning for us. We are now building the infrastructure for the entire industry. And what we do at LifeBit, we make the analysis of DNA data simpler and faster. And that enables our clients to develop better therapies and better drugs faster and while saving them quite a lot of money. Today, if you want to be sequencing your genome, it costs you just $1,000, or actually less than $1,000. Soon it will be reaching less than $100. As a result, by 2025, we're going to be having more genetic data generated than that of YouTube and Twitter combined. The industry is already generating more genetic data than they have the capacity to actually analyze. And as a result, more than 80% of the time of the people doing this job is wasted on figuring out computational tasks and data tasks instead of actually focusing on the results and the research they need to be doing, right? But what if, making sense of genetic data, of DNA data, was so simple, any one of you could do it, right? That would radically transform pharma research. And that's exactly what LifeBit does. We are building the world's first intelligent genomic platform. And the way we do it, we first solve the infrastructure problem and the application problem. The LifeBit platform takes you from an unscalable mess of different applications and systems to a scalable and modular application ecosystem. Then we solve the data problem. We put millions of genetic data, just the fingerprints of our users, and then eventually powerful AI learns from everything, analyzes users' interactions, and then eventually is able to reason like a human would reason about genetic data. And what this effectively does at the end of the day, it allows people that right now could actually do this job, which is about 20,000 specialized bioinformaticians, to over 5 million biomedical researchers that are now increasingly needing to make sense of this data, right? And our AI-powered technology doesn't stop there. It makes the analysis of these DNA data at least 30 times faster than is currently possible, leading into cost savings up to 80%. The analysis of genetic data is already at the core of clinical research, cancer, and genetic diseases. And fast, scalable, and AI-driven genomics is the future, right? And we at LifeBit are trying to make that happen. So that's us. Thank you.
Cool. Well, thank you very much for that. I get the great job today of just asking the questions, looking smart, whilst Maria actually has to answer them, which is great. Why don't we start by saying, you talked about doing a PhD, you've got a co-founder. Tell us a bit about that background. How did you get into this? Not everyone in the audience has kind of necessarily got a PhD. I'm sure some have. But where did you come from?
I mean, a lot of the problems that people deal, right, regardless of genetic data or any other type of data, they have a lot of data, right? And at the end of the day, what they are trying to do is make sense of this data, right, one way or another, right? And I think the first thing to do is understand your data, understand what are the questions you are trying to answer with this data, and then start applying simpler methods to just monitor statistics, just see what the data is telling you. And then from that point, either educate yourself or bring the talent that your business needs in order to start basically asking more, I would say, more intelligent questions or questions at a larger scale or larger cohorts of data, right?
And so how did you, because you came through, so I used to run Textiles London. You came through my program. How did you go from doing a PhD into actually wanting to start a company?
So as I said, when we developed this, or when we was part of the development of this framework, that this framework became then so widely adopted, then we saw a huge need, right? A lot of that happens in the industry, not just in this industry, in every industry, is that people are struggling with data, and genetic data are very, very big data, right? And very complex data. And the way people were trying to deal with that, it was just build these custom applications with all of these open source frameworks, and they were trying to do this again and again and again, right? And while providing support and consultancy, then we realized that what the industry really needs is automated software solutions that will abstract all of these hassles and will get them from raw data to the insights that they need. And that's what we are building at LifeBit, right? But I think that is something that can be generalized by everyone, right? Everyone is dealing with some type of data, and everyone would wish oh, can I just go from my raw data to the insights I want to be taking, right? The concept is just to start thinking, okay, how do I go and engineer the in-between part of that, right?
And so, I like what you said there. Nicole, for a friend, she asked how you would explain LifeBit to a 4-year-old. It's obviously not, she understands it completely. But there, if I've understood that correctly from you, it's basically taking extraordinarily large amounts of complex data and delivering insight. Obviously not, the whole audience isn't focused on genomics and bioinformatician work. How do you begin to abstract what you're doing through to sort of some more general principles around AI, and where does AI fit in?
That's a really great question. I always get this. So for most of the AI, it's actually data, I would say, right? Again, I think I've repeated data like 1 million times so far, but it's that important in our everyday lives. So data is the most important bit, right? So understanding your data is the first challenge, right? And what data you are dealing with. Then the next thing is, as Einstein was saying, if I had 60 minutes, I would spend 50 minutes trying to figure out my question, and then 10 minutes answering that. It's exactly the same. Once you have figured out the question, the data, you need to start figuring out the questions. What are exactly the questions that you are trying to answer with this data? But more than that, you need to be thinking how these questions can become actionable, right? Do these questions lead to your clients doing an action, to you providing certain insights that will lead to other actions, right? So that is the second thing. And then the third big thing is then trying to think around, okay, who are the people that could engineer the best solution for that, right? And then I would say a lot of, if you already have that knowledge, then it's all about brainstorm, okay, what's the best engineering solutions to get to that much faster? But I would say if you don't have that, then you need to go out there and say okay, who are the people that I need to get, right?
So how do you do that? How do you find great people?
How do you find, after a lot of pain and frustration, I guess. So great people are hard to find. But I would say, for me, great people are not just people that do understand, that have machine learning education and experience, but are also people that do understand your business, do understand the questions that you are trying to answer, right? Have a passion for that. Because these people then coming in, they are not just going to tell you, okay, yeah, here are the 5 fancy machine learning algorithms of last year, which one do you want me to deploy on those data? They will come in and they will say wow, I understand this question. Here's another 10 questions that we could answer, and here's how we can think about it and the different ways. And we had our engineers sometimes telling to us, it's just oh my God, this is just a regression thing. Or it's just perfect, right? And you need these smart people not to necessarily give you the most complex answers, to exactly give you the fastest and simplest answers to get where you want to go.
So practical tips, how do you actually go about finding those people?
How do you find practical tips? Okay, be very good at basically, the typical tips is just be very good at talking about your vision and the mission of your company. When you interview these people, be extremely good at telling them, educating them, and telling them, here are the questions that we are actually the big questions that we are trying to answer, right? Get them sold into the challenges that means. Get them sold into the impact of your business, right? And then get to speak to a lot of people, right? It's a people's game as well, right? Then when it comes to testing their engineering skills, well, there are a lot of methods. The one that we have found that works the best is actually putting forward like a machine learning paper or another publication that we find that is closest to what we want to be doing. And then we ask them, OK, first of all, we ask them to tell us what they do understand from that paper and so on and so forth. And then we tell them, like, if you are to actually take that same solution and apply it to our data with the limited knowledge that they have about our company, what they're trying to do, how would you go about it, right? And some of them is just like absolutely amazing seeing how they can brainstorm about things in ways that you've never thought about it.
So you start by saying that you've got to sort out the data, and you said that I think 80% of the time that people spend who are doing genomic analytics is about getting the data in the right form. What are you doing in terms of the infrastructure? Are you changing the entire? Are you putting in new infrastructure for the industry, or are you sitting on the cloud? How are you approaching that?
So, like with every industry, we are not changing the infrastructure because we're not an infrastructure company. But what we do, we take cloud and we take AI and we merge those two, basically, to try to analyze, and then then we democratize that process, right? We make it so easy for people to interact with our system. So we abstract all of the difficulties of cloud. We abstract all of the difficulties of AI, right? We automate a lot of stuff, and then we allow people to do the analytics processes much simpler and much faster than they could ever possibly
So tell me about that. Tell me about, because you've got relationships with AWS and Microsoft.
Yeah.
You talked to me previously about being cloud agnostic. How are you building that? That feels kind of an interesting challenge as the kind of starting point, which is, right, we're going to be cloud agnostic for the largest set of data in the world. Yep. That's an interesting little challenge you've set yourself. How have you gone about building that?
How do we go? I mean, for us, if you come to abstract what cloud means for at least us, and I think for all big data analytics, and what AI means, cloud in reality means just the computational power you need to be able to scale the analysis over this data. And what AI means at the end of the day means just automation and abstraction. That is what, at the end of the day, that's the benefit you are getting, right? So we start thinking in terms of those engineering teams of just like, how can we engineer the cloud, right, in a way where the experience to the user is just that, oh, this is just another compute engine, and that I don't care to think about, that I don't come to think about it, right? Similar, like, you don't really think about like the processor on your laptop every time you're trying to like run something or play music or something like that, right? You just go to the application, right? So why do people need to be thinking, oh, which cloud am I using? What type of cluster? Is it elastic where I'm storing? What type of machines, right? And when it comes to AI, right, when you go to Google and you start Googling things, right, Google search, then you start getting recommendations, and then Google starts learning you, right? You never come to think of just like, oh, how is Google recommending this, or how should I be thinking of that, right? So the experience is, again, similar for the user, where the user starts saying like, okay, I want to use this data and syncs the data into the platform, and I want to use this application with this data, right? And then it's just like that, right? And the system then takes care of all of the rest, and that is what we are engineering. That is the experience that we're trying to engineer to people.
So that does sound super smart, and you kind of you explained it pretty simply there, which is, you know, we just make it easy for the end user. How are you doing that? Other people are going to be thinking, shit, we need to build AI solutions that are amazing, an amazing experience like that. And you then you kind of went, oh, and then we get the engineering teams to do that. That seems like a challenging part of it. How do you do that part of it?
How do we do that part? Okay, so so a lot of the so we have, I would say, 3 different teams working sort of like in parallel. The more high-performance computing engineering team, they figure out basically all of the backend. They figure out how they're going to be deploying things and going to be merging stuff, right? So you need to have that team in place that really knows this big data and really knows cloud. Then we have the machine learning team, where all they are thinking is basically how they're doing all of the different optimizations, how they are doing the cost optimization, how they're training models to understand user interactions, to understand from basically, when a user is using a particular application with particular data, then what the machine learning people are trying to do is build a model that can understand what is exactly the question they are trying to answer. Are they trying to find, for example, if the patient has mutations that's causing him cancer and is going to die, what is exactly the question they're trying to do? And then we have basically the UI and front-end team where all of their job is all around like talking with users and just like understanding how right now they are going about, and we're just modeling all of the process of how they're doing with, how right now they are interacting with the genetic data, how they think about it, what are the software, the tools that they are using. So by having those three teams sort of like talking to each other, then yeah, the whole solution comes into play.
So if I kind of take a step back and kind of play back to you what I've heard, first of all, you've got to get the data in the right form.
Yeah.
Then you've got to have this really on the data management it's just simply in your mind data processing, and it doesn't matter whether that's AWS, Google, anything. That should be entirely irrelevant to the user. Then the AI is basically just again entirely invisible to the user, well designed. The way that you build those things is having a high performance computing team, a kind of an analytics team, and then a UI team.
Yes.
The bit that so that's a neat kind of framework, and I think it's applicable to pretty much any business. The thing, again, you glossed over something that's really important, which was, oh, and then I talk to a load of people, and then I hire the good ones. What's the actual process that you go? I mean, because it is a absolute shit show to find good people. How are you getting people to you?
How do we get people to us? Again, it's all about the vision, right? And then it's all about, I don't know if you have something specific in your mind.
I just don't know. I mean, obviously, so one of the things I'm joking about is that when Maria came through Techstars, we have a bunch of associates, and she hired half of them when she came out of the program. But you've expanded the team dramatically since then, and you found some amazing people. How have you actually? Is it through network? Is it through search? Is it through LinkedIn and going and finding? Is it GitHub?
Okay, so the tools we use basically, right? So network. I find most of my people through my personal network and through just going and talking to people, basically, because when you're a small startup, no one really knows you. Then we use all of the classical tools. We use a lot of recruiters. We are on AngelList. And through them, we have exceptional people applying as well. And we have, surprisingly, we try to have really good job descriptions that get people excited. And then when they come to us, then we have like very, very particular interviewing processes, as I said, to get them in.
To get the right ones.
Yes.
Yeah. We've only got a couple of minutes left, so what I'd like you to do is just paint, in 10 years' time, what is the future of genomics? What does that look like, and what's your play? What's LifeBit's? How do you participate in that?
So that's a really great question, and so if you come to think about it, what's going to happen in 10 years from now? Not even 10 years, in a couple of years from now, right? When we will be able, every one of us, to sequence genetic data, right? Because right now it's already like, it costs as much as it costs to buy an iPhone, right? But the reason why we are not doing it is because no one can understand, right? And part of that is also a big sort of like marketing problem where everyone is trying to tell you that, oh, genetic data is just like another type of health data. If I may say, that's bullshit. Genetic data is literally the code that makes you you, and the power and the insight that it can carry go way beyond health, right? So what will happen in 10 years is that once the costs are going to reach $100 and we will be able to actually be making sense of those data, then everyone will be sequencing. You'll be sequencing yourself multiple times across your lifetime. You'll be sequencing your favorite flower and your dog, and you're going to be having sensors everywhere, doing real-time sequencing of microbes in the air, contaminants, everything basically, right? Your foods are going to get personalized to your gut microbiome, to the microbes that live in your stomach. What you're wearing is going to come that. And what I honestly believe is that we heard during this conference a lot of amazing talks about like how different advances in AI are improving the way we're living life. And that's amazing. But if you come to think that there are areas where AI is not just going to be improving what we are doing right now, it's going to be enabling us to do things that we have never thought of doing, that's incredible, right? And in general, like health tech and healthcare and genomics is one of these big areas where not even myself can actually say what's exactly going to be doing, but I'm sure that people are going to be doing insane stuff. And as this expands to more and more industries, then what Live is hoping to be is to be the center that provides all of the software technology needed for businesses, but also individuals to actually be making sense of this data.
And on that note, that was an awesome summary. I hope people are feeling inspired and perhaps a touch scared about what that future looks like. But Maria, it's been a pleasure speaking to you. Thank you very much indeed.
Thank you. Thank you, Max.